Hey guys, it's STEM with Sid back with another video. Today I'll be explaining increasing and decreasing functions and the first derivative test. I kind of went over this, but a function is increasing when, let's say, x2 is greater than x1, like any two numbers x2 and x1 in that interval. And let's say in that interval where, let's say x2 is greater than x1, right? And let's say the function let's say fx2 is greater than fx1. Basically, the y value is greater than the previous y value. Then it's increasing. And then if you have fx2 is less than f of x1, right? Same condition. Meaning, as you move on, the y value is actually, into the right, has actually decreased. Then the function is decreasing. So increasing, decreasing. Now, that is the definition you learn early, but really we just care about derivatives. So if f of prime of x is greater than 0, then increasing. I know it's saying for all x in a to b, yep, and f is increasing on that a to b. But in general terms, f prime of x is greater than 0, increasing. If f prime of x is equal to 0, then f is constant. If f prime of x is less than 0, then decreasing. Okay? Now, you just pretty much, the first derivative test really is, let's say you found the critical numbers, like I showed in the previous video. You can, well, if you found the critical number to be, let's say 4, you can test out 0, anything to the left of it really, anything to the right, 5, anything is easy, right? And you can check, oh, first derivative. If first derivative is positive here, negative here, this is a maximum, right? And it's increasing here, decreasing here. That's pretty much like, and let's say you have more than one critical number. You have 2, let's say you have 2, 6, and 10. 3 critical numbers. Or let's add even -1 to that. And you have f prime. It could be minus here, plus here. Minus here, plus here. You know what I mean? Plus here, minus here, plus here, minus here. So you can be just going like this, right? And then, so this is a min, max, min, max. And you know where it's increasing, and you know where it's decreasing. Now, this can't, two of them together can't be minuses, because that means you're just decreasing and then decreasing more. There wasn't, there couldn't have been a 0. Well, it is possible if it's like, it is possible if you have a graph like this. Actually, the one I draw is correct. Like the f prime here there's no slope there. So if it's undefined, it falls, because critical numbers can be either 0 or undefined. So it could be undefined here, and you could have like negative and negative, because it's decreasing here and then it's decreasing here. So yeah, it is possible, but if the critical numbers all are f prime of x equals 0 and not f prime c is equals 0 and not f prime c does not exist, then it cannot happen. But yeah. You know where it's increasing and decreasing based on the derivative. So you just plug in, you just find the derivative of the function, plug in the value, and you will figure out if it's positive, it's increasing, negative, decreasing. If it's 0, it is constant. And you can pretty much do this with any function. It is the backbone or the foundation for, well, any function, like how it's graphed. Well, it's graphed, and then if you draw the f prime of it, it's just the slopes, right? If the slopes are positive, you got increasing part of the function. If slope is negative, you got decreasing part of the function. So here, f prime is going to be negative. Here, f prime is going to be positive. That's pretty much the principle we're using in this topic. Thank you for watching. I hope to see you next time. See ya.